This is question 3 of exam 1. It asks, compute the volume of the solid formed by the region bounded by graphs y equals sine x, y equals cosine x, 0 is less than or equal to x is less than or equal to pi over 4, rotated about y equals -2 using shell, disk, or washer method by A, sketching the region, B, finding limits if need be, C, finding the height and radius of the shell, D, setting up an integral of the volume of solid, E, finding the value of the integral. So first we're going to sketch the region. So it's between y equals sine x and y equals cosine x. And when sketching, we should note that at 0, cosine x is 1, and then at 1, cosine x is 0. So that makes it easy for us to graph. And then the opposite for sine of x, at 0, sine is 0, and then at 1, sine is 1. Now I'll move our unit circle closer so that we can see it. And then we see that sine and cosine intersect at pi over 4, which is part of our bound. So it's between 0 and pi over 4. Rotated about y equals -2. Then I'm going to expand our graph. Y equals -2. And expand it some more so I can include the inverted version of our sine and cosine graphs. And it'll all be rotated around y equals -2. So then our graph should look something like this. And we're trying to find this volume rotated. So now that we have our graph, we can move on to part B, which is finding limits if need be. So our limits are given to us here, 0 and pi over 4. So finding limits, A is equal to 0 and B is equal to pi over 4. So now we can move on to part C, which is finding the height and radius of the shell. However, this isn't really a shell, it's more of a washer. So we'll be working with radii here. So we need a different equation, which is A equals pi times outer radius squared minus pi times inner radius squared. And then if we rewrite this in terms of our graph, we would end up with A of x equals pi times, and then if we look at our outer radius, cosine of x, we'll see that it is 2 units. So that's what we're adding on to our outer radius, the cosine of x, because it's going up and away from the y. So it would be pi times the outer radius, 2 plus cosine of x squared minus 2 plus sine of x squared. And then, because we're working with volumes, our equation for volume in this case is the integral from 0 or from A to B is pi times big R, so our outer radius squared minus our little r squared, our inner radius, dx. And then if we were to rewrite this with our functions given to us here, we would do the integral from 0 to pi over 4 times pi, and our big R is 2 plus cosine x squared minus 2 plus sine x squared. Our pi dx. Our pi is a constant, so we can take that out when rewriting it. So we have the integral from 0 to pi over 4. And then if we were to expand the 2 plus cosine x squared, I'll solve it over here on the side so that we can see what it looks like expanded. So again, 2 plus cosine x times 2 plus cosine x. So we FOIL this. 4 plus 2 cosine x plus 2 cosine x plus cosine squared x. Then we can combine our like terms. So we have 4 plus 4 cosine x plus cosine squared x. And then we also FOIL the right side, which is 2 plus sine x. And I'll write this in red so that we can differentiate it. So we have 2 plus sine x times 2 plus sine x. FOIL. 4 plus 2 sine x plus 2 sine x plus sine squared x. Then we combine like terms. We end up with 4 plus 4 sine x plus sine squared x. And then from here, we just plug them back into our equation. Again, the pi is a constant, so we bring it out and we rewrite it as pi times the integral of 0 to pi over 4. And then times 4 plus 4 cosine x plus cosine squared x. And this is all in parentheses. Minus in parentheses 4 plus sine x plus sine squared x dx. And then from here we can distribute the negative and rewrite our equation once again. So we end up with 4 plus 4 cosine x plus cosine squared x minus 4 sine x and minus sine squared x, because again, we're distributing the negative here. Dx. And from here, we can combine like terms such as the 4 and the minus 4. And we write it as pi times the integral from 0 to pi over 4. And then in brackets, 4 cosine x plus cosine squared x minus 4 sine x minus sine squared x dx. And then from here we can group like terms together, and if we were to do that, we can see that cosine squared x minus sine squared x has a trig identity. So cosine squared theta minus sine squared theta is equal to cosine 2 theta. So that's what we'll replace those two with. And rewrite it as pi integral from 0 to pi over 4. Then in brackets, 4 cosine x minus 4 sine x plus cosine 2x dx. And then I'm going to expand the function so it's easier to look at and so we know what it is that we're doing. We have the integral from 0 to pi over 4 cosine x dx minus the integral from 0 to pi over 4 sine x dx plus the integral from 0 to pi over 4 cosine of 2x dx. So first I'm going to integrate this in red so we can differentiate it. And it's the integral from 0 to pi over 4. 4 cosine x dx. We'll take out the 4 because it's a constant. And then we're left with cosine of x dx. So the integral is easy to find from here, because the integral of cosine theta is equal to sine theta plus c. We'll ignore the c for now and come back to it towards the end. So now we have 4 times sine x from 0 to pi over 4. And now we'll integrate our function in the middle. And I'll do this in orange so we can differentiate it. And so we're subtracting it from that integral, and it's 4 sine x dx from 0 to pi over 4. Again, we take out the constant 4, integral from 0 to pi over 4, sine x dx. And looking at our trig identities, the integral of sine theta is equal to negative cosine theta plus c. And again, we'll ignore the c for now until towards the end. So then we plug in our identity, and it's 4 times negative cosine x with bounds from 0 to pi over 4. Now finally, we'll integrate our last function. And then we'll do it in yellow so we can see it better. Integral from 0 to pi over 4, cosine of 2x dx. For this, we'll do a u substitution just so that we know what we're doing and we can see it better. So our u in this case would be 2x. Our du is 2 dx. And divide both sides by 2 to get du over 2 is equal to 2 dx. Then we plug in our u substitutions. So we end up with the integral from 0 to pi over 4 cosine of u times du over 2. Our 1/2 is a constant, so we have to bring it out to the front. Integral from 0 to pi over 4 cosine of u du. And as previously stated, the integral of cosine that we used earlier is equal to sine theta, or in this case, just sine of u. And our u we can plug back in as 2 of x from 0 to pi over 4. And then we'll bring down our other functions that we wrote and integrated up there. So the 4 negative cosine x from 0 to pi over 4. And then the 4 sine x from 0 to pi over 4. And then we also started off with a pi, so we have to bring that down as well from before. Then our function should look like this for now. Now we're going to plug in our x values. So once again, I'll expand it some more. So it's 4 times sine of pi over 4 minus sine of 0 minus 4 negative cosine of pi over 4 minus negative cosine of 0 plus 1/2 times sine 2 times pi over 4 minus sine 2 times 0. And now that we have this, we can use our unit circle to help us plug in the numbers. Then we rewrite it once again. So 4 times, and then sine of pi over 4. If we bring our unit circle down, we can see that sine of pi over 4 is equal to the square root of 2 over 2. So we'll plug that in. And then the sine of 0 is simply 0 minus 4 times negative cosine of pi over 4. And again, that is equal to the square root of 2 over 2. And then negative times a negative is a positive, and the cosine of 0 is 1. Plus 1/2 times, and then we can simplify the 2 times pi over 4 to sine of pi over 2. And looking at our unit circle, we can see that that is equal to 1 minus sine 2 times 0 is 0. And now we can rewrite our function here as 4 times square root of 2 over 2 minus 0 is square root of 2 over 2. And then for this one, we distribute the negative 4. We end up with positive 2 square root of 2 minus 4. Then plus 1/2, because 1 minus 0 is simply 1, and 1/2 times 1 is 1/2. Now here we can combine our like terms. So we rewrite it as pi times 4 square root of 2 minus 4 plus 1/2 is equal to 3 1/2.